all we want to do here is learn how to convert from the normal distribution to what's called the standard normal distribution. So previously, we looked at a normal distribution, and we said that the normal distribution was this symmetric bell-shaped curve that had its center, both its mean and its median, at the center of the distribution here, where the mean is mu. We said also that the normal distribution followed the empirical rule, which told us the percentage of area that we could expect to find under each section of the curve, where these sections here are broken up based on the standard deviation of the data. So this blue area here represents 1 standard deviation around the mean. So from the mean minus 1 standard deviation on the left to the mean plus 1 standard deviation on the right. If we add on to that and include this red area, that represents the interval from the mean minus 2 standard deviations on the left all the way over here to the mean plus 2 standard deviations on the right. And then we have our interval for 3 standard deviations around the mean as well. But with a normal distribution, as we saw before, the mean and the standard deviation can take on any values. In fact, we said that the normal distribution could always be identified as capital N and then mean and variance. So for instance, if we had a mean of 5 and a standard deviation of 3, we could indicate that normal distribution as 5 and then 9, because standard deviation is sigma, variance is sigma squared. So if our standard deviation is 3, then our variance is 3 squared or 9. And in fact, we looked at that exact normal distribution. But the standard normal distribution is the special normal distribution where the mean is always 0 and the standard deviation is always 1. And we indicate the standard normal distribution with the capital letter Z instead of just any normal distribution with the capital letter N. So if we see capital Z, that's indicating the standard normal distribution. And of course, if we were writing this as a normal distribution, we could write it as capital N of 0, 1, because in the standard normal distribution, the mean is 0, the standard deviation is 1, therefore the variance is 1 squared or 1. So the standard normal distribution is just equal to the normal distribution that we've looked at before, but with this particular mean and standard deviation, which means that if we're sketching the standard normal distribution here, we have to indicate that the mean is at 0, and then by definition, the lower boundary of 1 standard deviation around the mean is -1, the upper boundary is +1, and then we have -2 and -3, and +2 and +3 for the boundaries around the 2 standard deviations around the mean interval and 3 standard deviations around the mean interval. So when we have a standard normal distribution, then these boundaries are always -3, -2, -1, 0, 1, 2, 3. Whereas in this example here, for the normal distribution with mean 5 and standard deviation 3, those values would have been a mean of 5. And then with a standard deviation of 3, we would have had 8, 11, and 14. And then here, 2, -1, and -4. Now, what we want to understand at this point is how we can take any normal distribution and convert it into the standard normal distribution. In other words, to standardize it. If we could have a way to convert any normal distribution into this super standardized normal distribution with this mean of 0 and standard deviation of 1, that would certainly make comparing normal distributions easier. It would make identifying values more clear. We could make our reporting more clear. It would just give us a good standard from which to start instead of starting with something like this normal distribution we looked at earlier with mean 5 and standard deviation 3, where we have all of these different numbers, and it's much harder to see that this is a normal distribution. And of course, as you may expect, we already have a way to convert from a normal distribution into a standard normal distribution, and it goes back to what we looked at earlier when we learned about transforming random variables. Remember that we talked about how to apply a shift or a scale to a random variable, and that's all we're going to do here. We're going to start with our normal distribution n, and we're going to apply a shift and then a scale in order to transform our normal distribution into the standard normal distribution. So if we start with a normal distribution, and instead of representing that random variable with n, let's say we're representing it with x, then the first thing we would do is apply a shift to x where we subtract out the mean. Now, let's talk about what this looks like visually. So this is, in fact, a sketch of the normal distribution with mean 5 and standard deviation 3. So what we're starting with here is the normal distribution of the random variable here with mean 5 and standard deviation 3, or variance 9. This is what its probability distribution looks like. Now, if we apply a shift by subtracting out the mean from every data point in our data set that's making this distribution, it's going to move every data point to the left by 5 units. The mean is 5. So when we subtract out the mean, the graph will shift and the curve moves over to the left. And now we have a distribution that is centered at 0, that has a mean of 0. So we moved the mean from 5 here to 0 here by applying this shift to all of the data points in our data set. So now we have the mean of the standard normal distribution, which is that mean of 0, but we still have a standard deviation of 3. We still have this wide stretched curve. So this curve we have right now, we started with the normally distributed random variable with mean 5, standard deviation 3. Now this curve that we're showing is the normally distributed variable with mean 0 and standard deviation 3. So we have the first piece of getting this over to a standard normal distribution. Now all we have to do is apply a scale. And here's what that scale looks like. We will divide every data point in the data set by the standard deviation. When we do that, when we divide by the standard deviation, that means every data point in the set is going to get pulled in closer to the mean in this case, and the resulting curve looks like this. And this final curve, after both the shift and the scale, is the normally distributed random variable with mean 0 and standard deviation 1, which of course we know to be equal to the standard normal distribution. So that's really all that we want to understand, how we transform one normal distribution into the standard normal distribution, regardless of the mean and standard deviation that we started with. And going forward, this formula here, after we've applied the shift and the scale, is going to be our next point of focus. So we want to imagine that we started with the random variable x, and after these two transformations, we transformed it into the random variable z. And now, if we rework this formula a little bit, if we switch it around and consolidate this side here, we get z is equal to x minus the mean divided by the standard deviation. And it's this formula that we're going to be focusing on going forward as we talk about what we call the z-scores that are associated with the standard normal distribution.